in this problem, we need to find the sample size for a particular confidence interval and margin of error. Now, we need one more piece of information here. We need the population standard deviation. So this is part 2 of the problem, and so I need to look at part 1 to get that. So let's take a look. Here we have sigma is 10 seconds. So that's what we'll use for our population standard deviation. All right, let's go back. All right, so now that we have sigma, I will find my value for z sub alpha over 2. Let's take a look at the formula first here. So the formula for calculating sample size is n equals z sub alpha over 2 times the population standard deviation, sigma, divided by the margin of error, and then we take that whole thing and square it. So I'm going to start by finding z sub alpha over 2. And a lot of times people just want to take this 99.9% and plug that in for z. And that's where we're going to get our z value, but that is not the value of z. So we have to compute z based on that. So how do we do that? I like to draw the normal distribution when I'm calculating a z value. And we have calculated z values, so we want to find the z value based on a confidence interval of 99.9%. So what does that mean exactly? It means that we want to capture 99.9% of the distribution. Now, from the empirical rule, so see, this is something that is coming in handy now. From the empirical rule, we know that we have between -3 standard deviations and +3 standard deviations, we have about 99.7% of the values. So since we want to go for 99.9%, which is really a huge interval, we're going to go beyond the 3 standard deviations. So we're going to be out a little bit further. So I'm going to, I don't know, just estimate something like this, right? So a little bit beyond 3, just to get that extra little 0.2%. And so what I'm looking for is, what is the z value that corresponds to those extremes? And because of symmetry, we really have one that's negative and one that's positive, right? So we're looking for z, and remember, we can find critical values, z sub alpha. In this case, we have z sub alpha over 2 because of our percentage being split between 2 tails. So that's where the divided by 2 comes in. So we can find z sub alpha, that's the z value that corresponds to an area beyond the z value. So when I look at this 99.9%, I'm going to take 100% minus the 99.9%, and that gives me 0.1%. And so 0.1% is the amount in the 2 tails combined. So I divide that by 2, and that gives me 0.05. And remember, this is a percent, 0.05%. So 0.05% as a decimal is 0.0005. All right, so let me make some room here. Now, in order to find the z value, what I'm going to do is I'm going to use the inverse norm function in the calculator. And I'm just going to go ahead and put in 0.0005. Now, this is not 100% correct. And what's wrong with it is that this is really going to give me this z value. So it's going to come out negative. But because we're using this standard distribution, I don't have to put in the mean and standard deviation unless you have the wizard in your calculator. So if you do have that wizard, then you have to put in the mean and standard deviation, which is 0 and 1, because standard normal distribution. So we're going to do inverse norm of 0.0005, comma 0, comma 1, and that's going to give me the negative z value. And I don't care, because this is going to be the same number, it's just going to be positive instead of negative. So one solution is just to take the negative sign off. And I'm going to show you what if you forget to do that. It's not going to matter. So when I enter this into the calculator, and remember that you get inverse norm by pressing second and vars, and then this is number 3 choice in your list for inverse norm. Okay, so you've entered that, you hit enter, and let's see, what do we get? So we got negative 3.291. I'm rounding to 3 decimal places. That's what they said in the problem. They said round your critical value, and this is the critical value, to no less than 3 decimal places. So there you go. You've got that. And let's see. So that's our value for the critical value. So now we can go back to our formula and plug this in, and we're almost done with the problem now. Finding the critical value is the longest part. Okay, so now I'm ready to plug in my value of z. And what if I forget to take the negative off? So the negative really shouldn't be there. I have negative 3.291 times sigma, which is 10, divided by the margin of error, which is 1.5 for this problem. And then we square. And this is why it doesn't matter if I still have that negative in there, because I'm going to square it anyway. It's going to come out positive. So should the negative be there? No. Does it matter? No. So do whatever you want. So I just wouldn't probably type it into the calculator, because who wants to hit an extra button? You don't want to take extra time to do the problem, really. All right, so I put that all into my calculator, and as an answer, I get, let's see, 481.3636. Now, this is not a valid answer, because we're asked for sample size. So you can't go out and get 481.3636 of whatever, I don't even know what the problem was about. So whatever the problem was about, you can't get that many of them, because it has to be a whole number. So when we find the sample size, the last step is going to be to make this a whole number. And how we're going to do that is we're going to say 481 was not enough, right? If I round this down like we normally would with a 3 here, we round it to 481, it's not enough, because they said get 481.3636. You can't just go, oh, never mind about that little bit. Now, does it seem like 481 people, or whatever it is, as opposed to 482 people could really make that big of a difference? It really doesn't seem like it, but in order to match what the problem is asking for, we do have to say that our sample size should be 482, or else we are falling a little bit short. So you're always going to go up to the next whole number in this type of problem, and that's how you get your answer.